So example 9 is asking us to solve the following equations. The suggestion is that we equate our indices with common bases. Now if we look towards this right here, it's mentioning that if we have the same base on both sides of an equation, just one of them each, then we can equate their exponents. That's really powerful. So what the goal is of a lot of this section is to turn any number into something with the same base on every side, and then we can actually move and organize everything. So if we look at A, it says 2 to the x minus 3 power equals 16. So our first thought here is, so we have our exponent as a variable, which we need to deal with. Well, think about how we can change things to have the same base. So if we look at our numbers here, then we have 2 and 16. They can be written in terms of the same base. So let me show you how that works. So 2 to the first power equals 2. 2 squared equals 4. 2 cubed equals 8. And 2 to the fourth equals 16. So what we can do here is say, well, 2 to the x minus 3 equals 2 to the fourth. This is perfectly legal because 2 to the fourth is the same thing as 16. And therefore, what we have here is, since we have the same base on both sides, we can say that x minus 3 equals 4. And therefore x equals 7. So this is a powerful tool for us throughout this section. So we want to make sure that when it comes to equations with different numbers as bases, and especially when we have our exponent as a variable, then we need to adjust. So our next equation says that we have 9 to the 5x minus 1 equals 3 to the x over the fourth root of 3, or fourth root of 27. Make sure that that's all right. Okay, so we look and we see that we have three different numbers. We have 9, 3, and 27. These are all very different, but what we know is that 3 to the first is 3, 3 squared is 9, and 3 to the third is 27. So we can use this to our advantage. The first step you want to make is convert any base to the same base. Okay, you want to think about your exponents. What is the most logical base to use? And then we're going to convert. Now your first step with this is to make sure that you replace every number with the appropriate base and exponent, and then leave everything else the same. So what I'm going to do here is I'm going to turn 9 into 3 squared. Now notice that's still to the 5x minus 1. We'll deal with that shortly. 3 to the x is fine. And we're going to convert the fourth root of 27 to the fourth root of 3 cubed. Now, this is essential because we can stack things that have the same base. We can stack their exponents. So we're going to move from here and say, okay, well, what rules apply to the things that we've done? One step at a time. Well, if we have a base to an exponent to another exponent, we can multiply those. That's the rule that we know. So this is going to become 3 to the 2 times 5x minus 1. When we multiply the 2 by each of these, we get 10x minus 2. Now, on the other side, we have 3 to the x divided by, well, how do we write the fourth root of 3 cubed? Well, if we remember from our flashback, what we do is we take the power over the root. So this becomes 3 to the 3/4. Sorry if that's a little sloppy. But now we have a start. Now we can move along from there. So we're going to keep 3 to the 10x minus 2 equals what? Now, at this point, we see we have 3 to the x divided by 3 to the 3/4. If we want to combine that with one base, so just 3, when we divide by the same base with a different exponent, we subtract them. So this becomes 3 to the x minus 3/4. A subtraction in an exponent means that we're dividing by something. We're taking away multiplication. So we can then simply state that 10x minus 2 equals x minus 3/4. So from there, now we have a pretty simple equation that we can solve. I'm going to subtract the x over, and I'm going to add 2 over. So I'm going to get 9x equals negative 3/4 plus 2. 2 is the same thing as 8/4. So I'm going to get 5/4. And I'm going to end up with x equals 5 divided by 4 times 9, which is the same thing as 36. So this is my final answer here. And this all comes from us converting all of our numbers, all of our bases to the same base, so that I can stack the bases, change all our exponents to where I can now set the exponents equal to each other, so that I can solve a simple equation.